All right. Thank you all for coming. My name is John Shea, and this is my partner in crime, Ted Malaska. And we'll be talking about the combination of Apache HBase and Apache Spark, and how we make the two systems work together, and what you can do with the two systems working together. So, a little bit of background. Ted Malaska is a principal solutions architect at Cloudera. He's one of the folks that goes out to the field, deploys this stuff, and helps our customers build applications using the systems that we distribute. He is the primary contributor on the Spark on HBase module, which is now part of the HBase project. And there's his contact information. My name is John Shea, and I am the tech lead and the manager of the HBase team in engineering at Cloudera. I'm on the HBase PMC, Project Management Committee, and I'm the founder of Apache Flume, and there's my contact information. So, what is on the agenda? What are we going to talk about? First, we'll kind of introduce the two systems. It looks like most of you are familiar with what they are, but we'll give you a quick primer on what they are if you're less familiar about them. We'll talk about the architecture and integration patterns that this library and these two systems have, and what we enable. Then Ted will talk about the typing and do some examples of using this API that we've added to the systems. And then we'll conclude with some future work, where we are today, and kind of the next steps. So, what is Apache HBase? Let me kind of read this off. Apache HBase is a distributed, non-relational data store that specializes in strongly consistent, low latency, random access reads and writes, short scans. And as a storage system, it's kind of an obvious place where we want to store RDDs, our resilient data sets, right? And where we'd want to read them from as well. It has this very important low latency quality. Apache Spark is a distributed in-memory processing system that can be used for batch and continuous near real-time streaming jobs. So it's a way to process lots and lots of data. And it makes sense that you'd want to be able to read data from the storage system, process it in a very fast processing system, and then write it back out to the storage system. Spark's programming model is built on the RDD abstraction, the resilient distributed data set, and the newer version of it, which is the data frame. So, what are some example use cases? So these are some actual cases that Ted has gone out and deployed with actual customers in production or pre-production stages today. So we use it for streaming analytics to count things, basically, as they get fed into Kafka and then to HBase to replace a Lambda architecture. So the primary use case here is web logs and counting things from our web logs for this particular customer. We also use it for ETL, so we process data as it comes in, and we write things out to files and use HBase's bulk load mechanism to atomically and quickly and very efficiently load data into HBase so it can start being served. On the other side, we can actually use Spark SQL to extract layer from HBase and kind of have SQL-like queries written inside of Spark that we can ask questions and perform operations and computations on. And these last two use cases are handling on the order of 25 to 50 billion entries per week, roughly about 20,000 entries per second. OK, so let's talk about the patterns that we have. So HBase basically has three ways of getting data in and three ways of getting data out. We have our near real-time. Let's try laser. Yes. We have our low latency, near real-time operations for reading and writing. Reading on the right, writing on the left. We have this kind of mid-tier HBase replication that's somewhere between low latency and high throughput. And then we have the extremely high throughput bulk import mechanisms and snapshot, map, reduce, and full scan mechanisms of HBase for bulk reads of data and bulk writes. So you're kind of picking, based on the way you're reading and writing data, the low latency approach or the high throughput approach. Let's take a step back and talk about how we used to process data and how a lot of people still do today. Well, what you would do is you'd use HBase with MapReduce. And you'd use it to do batch processing. And what you would do, it was to read data, you would use HBase's MapReduce input formats. And we have three that are the most common: the table input format and the multi-table input format. which uses the low latency read operations for HBase, and the table snapshot input format. So this is what you would use if you were to have a table, take a snapshot of it, and work directly against the snapshot of the data. It's about 3 to 5 times more throughput if you use that approach. Similarly, for writes, you have 3 output formats that are fairly common. You have the table output format and the multi-table output format for real-time writes into an HBase cluster, and the hfile output format, which processes all the data, writes it to a file, and then bulk loads it atomically into HBase for very high throughput loads of data. So what does this picture look like with Spark? It looks almost identical, right? What we are essentially doing is we're replacing MapReduce with Spark and using the Spark API instead. And instead of reading a table, we're reading an RDD or a data frame. And instead of writing a table, we're writing it through an RDD as well. Nothing has really changed here. We're using the same input and output formats that HBase provides, and Spark allows you to use these for batch operations. Yeah, they're pretty much the same. That's great. That's great if you want to do batch operations. But there's other things that you'd want to do with HBase data as well. This isn't really taking advantage necessarily of the real-time reads and processing that the two systems provide. I got to point this way. There you go. All right. There's another subsystem, which is the Spark streaming system, which is the processing system for handling data in near real time. And the main thing that we're doing here, this is a gross simplification of what's going on, is we feed data into Spark streaming. It creates a bunch of mini batches. And then it essentially uses Spark to process the data in these RDDs, and then outputs a bunch of modified RDDs. Right? So partition, compute, output. 1, 2, 3. What we actually enable is adding HBase to this equation and adding it so that we use HBase efficiently against the streaming data. So really what we're doing is we're allowing the join of the Spark streaming data with HBase data. And you can think of this as for a use case for enriching data as it comes into the system, and potentially writing the enriched data into HBase once we do the processing.
Can I add a little thing?
Yeah.
So if you were in my last talk, we talked about exactly once processing with Spark streaming and how you can keep state in like the update state by key with Spark streaming. With this, you can just do puts into HBase, so you can have exactly perfect counts stored in HBase, and then you can retrieve it later on with SQL or other APIs. Okay.
So the main addition here is that we basically allow you to process the data as you would in Spark with near real time, and read and access and write data into HBase in near real time. So it's kind of marrying the two really nice properties that these two systems provide. So we had our picture here before about like how we get data into and out of HBase. And what we've done is we've basically added 2 things. We've added the streaming so that we can get and put data into HBase in near real time. And we have the traditional batch mechanisms using the RDDs or data frames to batch insert or to batch read data from HBase. I'm going to hand it over now to Ted so he can talk about typing and how the API is used. So left, right,
perfect.
Laser.
Oops, sorry. All right. So I know a lot of you may not be able to see all the code, so I'll try to walk through it. These slides will be up somewhere, I'm assuming. But if not, there's a really good blog written by, there's a decent blog that's written on Cloudera by me. But okay, so this slide represents the basic fundamental concept. It's really simple. We push the configs up into the executors, and then we make the connections once and we leave them live. This also applies to the Kerberos authentications and stuff like that. So the idea is we're not reestablishing the connection on every Spark streaming iteration, and we're not re-authenticating with Kerberos on every single iteration. So pretty basic, right? And then the next thing is giving functions that are supplied the connection, right? So then they get supplied the records and the connections at the same time, right? because then you can do stuff. All right. So this is just some starter code. There's nothing really fancy here. The beginning is just showing how you would essentially take a Spark context. You would get all your HBase configuration stuff. And from your Spark context, you would make this thing called an HBase context. So where did the HBase context idea came from? I was working with TD, who's the Spark contributor of, and the Spark streaming guy. And this kind of represents very similar to the graph context kind of a thing, or the Hive context, right? It's something that has additional information that the Spark context doesn't have, right? All right, so just inside here are like broadcast variables and stuff like this. Now, if you aren't familiar with Spark, has anybody ever seen Parallelize on Spark streaming? Spark, okay. If you haven't, this is so cool. This allows you to do unit testing and testing on your local machine without a cluster, right? So no one should have a job fail for never have running it on their IDE. But anyway, so this is our setup. We have a HBase context, and we have a sample RDD with data. So we're going to walk through doing a for each, a map, a bulk load, a different type of bulk load, a bulk get, and a bulk delete. All right. So in for each is like a execute this function distributedly across the cluster, right? That's how it works. The main modification here is instead of just getting an iterator, we get an iterator with a connection. So now we can do anything we want with HBase while we iterate over our data. I had one customer that was doing graph restructuring as the data was streaming in, so they could go look at the current nodes, see if new edges needed to be made, if new connections needed to be made, and then add them. So it could do multiple gets and puts in a single iteration if it wanted to. But really, this is one of the fundamental classes that a lot of the other classes are built on. Okay. All right, so then the next one is a variation on the for each. It's just the map. The difference here is you can return values, and those return values can create another RDD. So from the values you get in, you can do gets, you can do scans, you can do whatever you want, but you can also return something to create an RDD. And I think flat map is recently added, or it's about to be added. Okay, so now we get bulk load. Now I have two types of bulk load. This bulk load is very similar to the first, and there's actually multiple MapReduce bulk loads too. This one will work for tables of any column length. So if you have columns that are 3 million columns deep on a row, this will still work, right? Yeah, and I think the MapReduce one used to have a problem where it broke. I think they might have fixed it. But this one will work on extremely wide tables. The problem with this one is every column gets sent over the shuffle separately, so it's very heavy on the shuffle, right? Which takes us to the second implementation. The second implementation, and my code could have been cleaner on this, so forgive me, is for thin rows, right? The idea here is if your row is less than, I don't know, like 10,000 records or so, it all depends upon memory. But if your row is less than a certain number of records, what you can do, and if you know all the, certain number of columns, and if you know all the columns at the time of the map phase, you can just send the whole record into bulk load. What this does is it reduces the amount of individual records in the shuffle, making the shuffle more efficient, making your bulk load faster, right? But behind the scenes, there's a lot of shared code between this and the MapReduce version, and I think we actually pulled out the shared code, and they're both actually implementing the shared implementation. So if one has a bug, they both have the bug, and if one's fixed, they're both fixed, which is kind of cool. Oh, and a lot of this was inspired because I went to a customer, that billion record customer, that said, we'll pick you, you can help us, but I don't want a single MapReduce job on my cluster. So a lot of this was inspired by that. All right, so the next thing I'm going to show you is this idea of bulk gets. And whenever I show bulk gets to a MapReduce person, they're like, why don't you just do a multi-get? Or why don't you just do a scan? That's totally legitimate. But let's say you had to do a multi-get of 1 million records, right? Wouldn't it be nice to distribute that multi-get? So bulk get is a distributed multi-get. Okay, hope that makes sense. So, and then it populates the RDD in that fashion, right? And it's really, oh, we skipped from get. Okay, we skipped from get to put, but that's okay. Imagine this put is a get. And essentially you would be creating a put object, a get object. This is the example of the other way around. Maybe you don't want to use bulk load. Maybe you want to do a bulk put. This is very realistic in the case of like a Spark streaming or something like that, right? You wouldn't want to be doing bulk load jobs during Spark streaming. That might create a lot of H files. And then we have also bulk get, right? There might be a situation where you want to delete a lot of records, right? All right, now this is, I think, the more interesting part. Man, are we going to finish really early? I apologize. Should I be going into every single attribute? Okay, we're going to go into a lot of questions. We're going to go a lot of questions. All right, so Spark SQL is amazing, and they have this amazing interface called the default source, which is really nice. And it allows you to interact with, it's an interface that allows you to interact with any underlying storage system. We modified that so it will work with HBase. It's gone through probably the most amount of patches of any of the things here, just because there's so much we can do with this, and we're just scratching the surface. So what we have right now is well, let me walk you through how it works, and then I'll tell you what we have in it. So first thing you have to do is you have to create a mapping between your HBase table and your data frame. And the thing here is because HBase tables don't have schemas, right? So what you're doing here is you're telling Spark SQL is if you find this column in this row, map it to this column in the data frame, right? If you don't find the record, because HBase is a sparsely populated system, just return null, right? If there are other columns that aren't defined in here, I don't care about them, okay? So there you do the mapping. Now this line right here is not specific to us. It's this Spark specific function, which is register table. So in Spark SQL, you can register a data frame as a table. And what that does is it allows you then to write a SQL statement that references that table, which is right here, as a total normal SQL statement. So if I was pointing that to Hive, it would be the exact same SQL statement. If I was pointing that to Kudu, it would be the exact same SQL statement as it is to HBase. So SQL is SQL is SQL, which is really nice. The SQL has no context that it's an HBase SQL. And then you can see here we're printing this out. So let me tell you really quick about what type of things have been added to SQL and what type of things are probably going to be added to in the future. So the first thing is you can do bulk scans, right? It also does push down filters, right? So if you have a filter, the filter actually happens on HBase. It doesn't actually happen on Spark SQL. It also can figure out if you're doing ranges on primary keys. If you're doing ranges on primary keys, it's going to do micro scans instead of scanning over the entire table and then just filtering out except those ranges. And then the other thing it's going to do is if you use an equal sign with a primary key, it will use a get. It won't use a scan. So it'll come back super fast. Okay? Some things that we haven't added, there's so many things we haven't added. We want to make the underlying storage in HBase configurable. Right now, it's every column to every value, right? And the values are very similar to what you'll find in the byte class, where it says to string, from string, that kind of stuff. But wouldn't it be nice to say, oh, maybe I want to store it as an Avro record, where it's only one column, or something like that. Have it pluggable. So that's something we want to add. Being able to do an insert or an update would be hugely powerful, right? So in the end, dealing with HBase could be as easy as just dealing with SQL and Spark. All right, any questions on this? I saw a hand all the way in the end. Nothing? Okay. All right, so this is one of my favorites. I love this. So why is Spark SQL so awesome? Does anybody know what MLlib is? Has anybody used MLlib? All right. This is, let's count them. 1 line, 2 line, 3-line, and I don't know, a couple lines here. And that's just to print it out. And that's to go from HBase to MLlib, right? So we run a SQL statement right here, just like a regular SQL statement. It gives us a data frame. We can do a map job on that data frame and change it into vectors, right? And then we have a vector RDD. You don't actually have to do this count. This is for debugging purposes, so scratch that off. That doesn't count. And then you don't even have to do the if, because we're assuming we're perfect and we're always going to have data. So that doesn't count either. Now, then we can run just k-means on that vector, and then we have our centroids and our clusters, and we can output that. So that's cool, right? Come on. Just a little bit? All right. All right, where else are we? And future. Were you going to talk about future?
Do you want me to do it, or should you? I can do it. Or...
You can do it.
All right.
And
thanks.
I went too fast.
All right. Oh, yeah. So, we did a quick summary of the batch analysis that you could have done straight out of the box with Spark. We talked about the streaming patterns that we added, the integrations that we can do enriching joins with Spark and HBase data. The good news is that this is available upstream in the Apache HBase 2.0 branch today. So this is something that if you were brave, you could go get the master version of HBase and start running with it and start trying. If you're less brave, you can go download CDH 5.7 and download it. We offer commercial support on this as of April 7th, which was a week ago. The good news is we also, we've had this in production or pre-production with about 10 of our Cloudera customers thus far, and we imagine now that it's actually GA with many more soon to come. Some recent additions, Ted had mentioned some of them, but a lot of our users use Kerberos and use security. How many of you all use that? Right, so that's like a third of you guys or a half of y'all. So we've added things that we make sure that, and this is in the 5.7 version, so that we can work with Kerberos protected HBase and HDFS clusters as well. There's one caveat right now, and it has to do with ticket renewing. So this is specifically for the long-lived Spark streaming jobs where you're working with HBase. Unfortunately, today, you have to restart processes about once a week when the ticket expires. But we're working on a solution for that, and hopefully we'll have a solution out for that in the next maintenance release.
And we actually have one customer on the solution supported by services. But yeah, it'll eventually come out.
Yeah. So we're betaing that with basically a customer right now, and that'll translate over to regular support with our offering. And then Ted had mentioned Avro, but we also have basically another way of specifying the schema when you're specifying the mapping for reading data using a JSON mechanism. And this was contributed by Zan, who I don't know if he's here or not. But so there are more additions to this coming. I think, though, it's very useful as it stands today. Some other future things, we saw this graph, right? And we have 3 different categories of reads and writes. We have this real time, and we have this batch use case. But we have this third line here, which is getting no love. So what could we do there? And this is kind of speculative of things that we could do, and we can talk briefly about the use cases it would enable. What if we actually added HBase replication as a source of data? And the way that would look is something like this. So HBase replication, basically all the edits coming into an HBase, could now be fed potentially, let's say, to Kafka, and now serve as a source for Spark streaming. And combine that with the ability to join data with Spark, join data with HBase when we do our Spark streaming job. We have the potential here to do change data management kinds of use cases with this kind of architecture. So this is not being built yet, but this is something that could be done. And it's very clear that this is something that is a distinct possibility in the near future. Then it's the same idea. We gather data, except now it's from the HBase replication stream. We do some computation. And we write it back out, either to files or to HBase or whatever other destination you prefer. With that, I think that's all we had prepared. I think we have a couple more slides if we could go, if you wanted to go in more detail about one of the use cases.
Let's see if they have some questions first, and I can walk through Spark streaming and HBase. There's some really detailed slides, but if you have any questions, let's go through that first.
Yeah, so we'll open up for questions.
Is it possible to create an RDD from HBase table.
Yes. So an RDD.
Yeah.
So is it possible to create an RDD from an HBase table? You have multiple options.
Okay.
All right. You can use the RDD map function and do gets as you iterate through your data. You could
Slow.
use, huh?
Slow.
I'm working. You got multiple options. We're working on it. You can do the bulk get function, which essentially will batch a whole bunch of things and then do a get. I know, still slow, still slow. All right, next one. But those have use cases. There are real use cases for that. The next one is you could use the Spark streaming, the Spark SQL, which will essentially do distributed scans. Okay, so that's a little bit faster. The one that I don't think is there right now is distributed scans over a snapshot. Is that there? I don't think that's there.
If you do that during the batch use cases, if you're using the input-output formats, you can do it from a
that
snapshot.
would work. But the Spark SQL doesn't go through it yet. But there's no reason why we couldn't.
Okay, thank you. And another question: how you ensure consistency? RDD on top of HBase should be immutable. What if you have something?
That is a
modified?
great question. So his question is, and this came up when we first designed this. Me and TD were talking about this, and he brought this question up. And at first, I'm like, I don't care. So what is this question, and why is this really, really important? So the whole idea of RDDs, and RDDs are immutable, right? And if you use a lot of these, the code that I showed, potentially, if there was a failure and you had to re-get the data from its source, and there was a mutation, you would get different data, right? Totally realistic. There are options, right? They're not the best options in the world, but there are options, right? One is you could use versioning, and you could use timestamps. That's definitely one. There is also the get functionality where maybe you're storing your data in a certain manner, like if you're doing like a OpenTSB type structure, and you're querying something like that, that you could be smart enough to know this is when the time zone that I started querying. Don't query past that, right? So it's not super clean and perfect, but you could do those things.
Or snapshot.
Yeah, you
Or
could also do it from
snapshotting.
snapshots.
Yeah, any of those would work. But you're right. But there are use cases where that's not as much of an issue, because when you get things like, let's say you're using Spark streaming, right? There are ways that you can do Spark streaming so you could recognize that so if you had to redo part of Spark streaming and you did a get and you said, oh, you could have put the offset into the record and say, oh, this was part of the batch that failed. I'm not going to mess with it. I'm just going to keep going. And that could be used also to identify duplicates and stuff like that. So it is a problem and it isn't a problem. It's both.
And then one thing to bring up also with snapshots is they have consistency at the region level, but each partition, if you have data that's reading to different regions, we're not going to guarantee consistency at that level. It's still the same level of HBase guarantee, which is per row level consistency with the snapshot.
Okay, thank you.
Any other questions?
Any other questions?
I have some questions about the sort of using HBase as a left side join against some streaming data, and I was just wondering if you could articulate a little bit more about that use case. Did you actually implement that somewhere?
Left side join.
Oh, sorry, the right side of join. So where you're
It's that.
you're streaming the.
It's not the one that I was doing the counts.
No.
No.
We could go to it.
Oh,
It's-
the previous one, when I was doing, when I was gathering information, right?
Yeah.
Sorry.
With the gets.
Can't remember exactly.
it's this one.
So was it the one where I
Yeah, join a data set with HBase data. So yeah,
Yeah, so like I said, I had this one customer that had in HBase. Do you remember how many trillions of records they had? You know who I'm talking about.
I don't remember.
It
It
was
was on the order of billions a day, right? So.
Yeah, so they would add probably let's say 20 billion a day,
Okay.
and they kept 3 years of data.
Yeah.
All right, so scans were just not going to happen. And what they needed to do is during the day, when things came in, they had to run some business rules. And these business rules required to look up a couple other records. right? So what we would do is, well, this was initially written in MapReduce, and this was written for them. They haven't ported yet. But what you could do is in a micro batch, you can gather up a lot of those gets, go get them all really efficiently with bulk gets, right? And then process them with the data at that point. Does that make sense?
Yeah.
So, yeah, I mean, it's not right in all circumstances, but in that circumstance, it made a lot of sense because they could do their validation and do it at scale. Their latency requirement was like 10, 15 minutes, so that wasn't an issue. But it was the throughput that was really important to them because 10 billion a day with the amount of business rules they had, and they had pretty complex business rules, was a lot to do.
This was like a financial agency of some sort.
Yeah.
And the ingestion, that's actually the order of magnitude of our problem. The ingestion into HBase of that at sort of the key value level of all that 20 million records, it's a referential data, that's relatively efficient.
So that goes into a little trick that I did.
Okay.
So, so HBase, if anybody knows HBase, and you don't have to count it out, the most important thing for success or failure to HBase is your row key. Like, there's nothing else. If you fail on your row key, you're done. Right? Your first decision is success or fail, right? So what I did was I found a row key. I don't know, that sounds kind of geeky. But as H files were being added, the row key was such that no matter how many H files were in a region, I would never look over more than one.
Okay.
It was pretty badass. So, so my get speeds never degraded. And that was very, very important. And in that world, since my get speeds never degraded, I never did major compactions. I let minor compactions just go all the time. So minor compactions were just a constant. You know how some people are like, major compactions ruin my day. I had compactions constant. That was just a norm. But yeah, so it depends upon row key design. So if you did a bad row key design and you had a lot of H files, which you probably will if you're going at that level of data going in, if anybody doesn't know, if the data is not in your block cache, oh, that was another thing. Let me mention that. I cheated on that too.
No, it's
The
not
best
cheating. It's
architectures
optimizing.
is all about cheating. Okay, so if it's not in your block cache, and that'll be the next cheat. I'll tell you that one in a minute.
Optimization.
What you have to do is you have to go to disk. But if you have multiple H files, and each H file has things called Bloom filters and ranges, and these are the tricks I use. And if you can't distinguish if the record is in there by the Bloom filters and the ranges, it actually has to look in every H file. And that is a seek per H file, which is expensive. Anyway, so we don't want to do that, right? But so how do we take advantage of the block cache? So, all right, you guys ready? So, okay, the other trick I had with the row key design were things were semi-collocated based on time. That's how I would cheat on the H files, right? And because they were entity-focused and time-focused, and so much was coming in, and so much was coming in that was close to now. Like, not everything was guaranteed to be close to now, but it was like a 99% chance that things were close to now. Like, some things could be 2 days old, but most of the stuff was close to now. What I did was I did a reduce before I did the get, so that the records that I was getting was in the perfect order they were in the regions, and I would get in that order. And the way that I'm going a little low level if you guys are okay with that. The way that HBase gets when it gets a record is it gets a block. It doesn't get a record. It gets like a 64K block. Well, because they were so co-located, they were just there. So my block cache hit rate was like at 99%. Not because I had the biggest block cache in the world. This was before all that memory shit that they added, which is awesome. But this was before that.
Come see the next talk that I give, probably about 6 months from now.
Yeah. But this was before that. But because I would get one record, I would be pulling back 1,000 more that I would be using. So again, you got to cheat. It's all about row key design. It's all about knowing your access patterns. I don't know if that'll apply to you, but it might.
It seems like it. We basically have a start of a bunch of.
And you're supposed to give me a ticket to Paris anyway. So let's do this. Let's do this.
We'll talk about this later.
Yeah.
Are there any other questions from folks in the audience?
But yeah, just to note that without block cache and without the shuffle, I was getting 3,000 events a second out of HBase in terms of gets per region server. Afterwards, I think I was getting, I want to say I was getting like 100,000 events a second. It was like magnitudes. It was ridiculous. So when we did the first test without any of the tricks, the client was just like, who are these jokers? Like, this is not going to scale. But you can imagine how that would work. If we're only doing one seek and 99% block cache, we're in a much happier place. And when we're doing the gets, we're doing like 1,000 at a time. We're not doing 1, 2, 3s. And we're doing it in parallel. So goodness all the way around. All right, any other questions? No? Okay, one more. Okay, yes.
How do you handle filtering for row keys when they are not located yet?
Say it one more time. How do I?
How do you handle filtering the row keys?
Filtering?
Yes. Like HBase filtering or do it at RP level?
In that scenario, I didn't have to do filtering. I was doing bulk gets. I wasn't doing a scan.
If it's not in collocated, so it's spread around.
If it's spread around, I would have to know the exact use case to see if I could cheat. But if it's spread around, filtering is not your answer because you're going to be reading so much data, right? So,
You'd still get some benefit. Like you'll
definitely.
still have the block cache
if
help.
You're forced to scan.
Like you would get that block and you would get the caching for that particular set of data, but you'd have to go out to get the next set, the next block of data.
There's also a really nice paper about, so totally unrelated to your question, but a really good read. There was a client that, actually this now gives away who that client was. There was a client who wrote a blog on the Cloudera blog post about entity-centric time series structures similar to OpenTSDB. And being able to do a bulk scan. So you know those data structures as it's an entity, and then all the events that happen to that entity, and then another entity, and then all the events that ever happen to that entity, right? What happens if you just want to do a bulk scan on everything that happened Tuesday for every entity, right? And what we did was we wrote a custom input format that did exactly that. So it would just do distributed scans on the little microsections. But yeah, I would have to know the exact use case because maybe there's something we could do with the row key. Maybe there was some way we could cheat. It's all about cheating.
It's all about optimizing. Any other questions? We have about 2 minutes left.
One comment you mentioned listening to the changes in HBase. A while ago, I had a read about a company who wrote a HBase side effect processor.
Yep.
How is that different from what you're applying?
So let me bring up that picture really quick. I have to fast forward. So we actually use a pattern very similar to this today. It's with the Lily SCP processor, and basically, this is how we. Come on, we'll get there. This is how we do our integration with Apache Solr. So instead of having Spark Streaming here, we have Apache Solr here, and basically we can take particular entries from an HBase row and feed it to the text search engine, and do it with fault tolerance and do it with all motherhood and apple pie for distributed systems and distributed. And we basically have the ability to, if you imagine this instead of Spark Streaming saying Apache Solr, create text search indexes of data in HBase. And it could either have the data or it could point back into the particular row in HBase. This is the same idea. It's just that right now this implementation is very specific to that integration between HBase and search. And the idea here, the idea here would be to make it more generic so that we could make it the integration point for Spark Streaming, make it the integration point for other systems and tools that may want to take a look at this edit stream.
Yeah. So when he does this, was anybody in the other room with me? Anybody? Did anybody see the Minecraft demo? The moment he does that, I'm totally doing the Minecraft demo on that. So the Minecraft demo, I don't know if you saw it.
I did not.
He was in real time with Spark Streaming, plotting traffic or stuff on San Francisco.
Yeah.
And it would be really cool just to do a demo.
Yeah.
As you could plot activity on HBase in a three-dimensional way, so you could view the use of HBase in a three-dimensional way. It would be pretty cool. But if you put Kafka here, that means anything would work, right? And you can't do Spark streaming straight to HBase because then you got issues, right? I mean, it would work, but you got issues because Spark streaming needs those guarantees that Kafka gives you.
It's like the n square problem, right? If we have to connect this thing to every single system out there, you end up with n connectors. And then, oh yeah, we might want to connect on the other side as well. I mean, this is HBase replication. It's called HBase replication because this is how we replicate data from one cluster to another. But it makes total sense for like a change data model kind of use case to feed that thing to a different system and have it process the data and see all the data that came into HBase as well.
Yeah, something like Kafka would be my preference also.
Yeah, and that's what it would be right there.
There's definitely some caveats in here right now. So like we've recently added the ability to replicate bulk loads into HBase, and that's something that I don't know. I mean, I don't know how Kafka deals with 10 gigabyte files. So there's still some things that we need to solve there for all use cases. But for like a basic use case, a limited use case, this is very feasible and very it's something we could probably prototype really quickly, but to make it production worthy for everybody, it'll take a little bit more time.
And another one I can imagine, and I know we're over our time, but she hasn't raised the sign yet. Some people have very thin networks between their clusters. So let's say you're doing replication, you have a thin network. Well, if you pumped it to Spark Streaming, your Spark Streaming could then use Spark SQL to save it as a Parquet gzipped file, which is probably like 10, or maybe like 5 times smaller than what it is normally, something like that. But if you have a thin pipe, oh, we're done. Raise the sign.
Anyway.
Yeah, that would make, more data through the thin pipe. Your latency would go up, but if you got a thin pipe, you may need it.
Thank you all.